Hello, Algebra 2. We are going to go ahead and finish up this unit. You guys have about 2 more days left before your test. This is the last night of notes before your test, so we're going to spend the rest of the time that we have before your test to review. So go ahead and set up your notes. You've got day 4. This is long division, which should look familiar to you. Last time you guys did long division or learned long division, it was in elementary school, and you've been doing it ever since. So we'll review that, and then synthetic division is a new style of division for dividing polynomials. All right? So how do we use long division to find zeros of polynomials? We are going to start with just a review of what long division actually looks like, all right, since it's been a little while. If you guys wanted to divide a large number by a small number, I'm going to go ahead and put the small number on the outside of the division symbol, and then I'm going to put 472 on the inside. What I'm going to do is look at the very first position, which is our hundreds position here. I'm wondering how many times does 3 go into 4? Or what is 4 divided by 3, right? So 4 divided by 3 is 1, and then there's a little bit of leftover. But I'm going to go ahead and put how many times 3 actually does fit into 4. So then I multiply the 1 times the 3 to see what I have left over. So if I take 1, which is in my hundreds place right now, times 3, that would give me a 3 here, which is really representing 300. And we are going to subtract what we have left. So 4 minus 3, that leaves me with a 1. Since that's my hundreds place, I'm going to go ahead and bring down the 7. Okay, 7 comes down. And now I'm thinking, well, 3 doesn't go into 1, but 3 does go into 17. So 17 divided by 3 gives me 5, because 5 times 3 is 15. All right, so now I have 5 times 3 is 15. I'm going to subtract these two. The 7 minus 5 is 2. 1 minus 1 is 0, so I don't have any hundreds left. And then I bring down the last number, 2. 3 does go into 22. 22 divided by 3 is 7. And 7 times 3, I'm going to multiply those two. I'm going to, running out of space here. 21. And I subtract, and I have 1 left. So that means I have a remainder of 1 that I'm still trying to divide by 3. All right, so the way that I would write my answer then is 157, right, plus I'm still trying to divide 1 by 3. That last one won't divide by this 3 that I started with. So I have 157 and 1/3 left over. All right, so my steps are to divide. And we're going to talk about dividing by the first term. Here we divided by our largest space holder here. So, well, our largest position. So we divided by hundreds position here. But we want to divide, and then we multiply. Once you multiply, you put your answers right underneath. You line up. You got to be very neat with your lineup. And then we subtract and bring down. Okay? So these steps hopefully sound familiar, since I know that you spend a lot of time on them before. Subtract and bring down the next term for us today. And here it was bring down the next position. All right? Okay, so divide, multiply, subtract, bring down. Those are our steps for long division. How does this work with polynomials? Because that's really what we've been spending our time on recently. So I wrote over this here, but finding all zeros of a function using long division. That was my question originally as well. How do we use long division to find zeros? Okay. Well, in this case, these questions are going to be written a little differently, but you always are going to be looking for more zeros. And we're starting with 1 0, or one solution. X equals 2 is one solution. We've talked, though, that if x equals 2 is a solution, then x minus 2 is a factor, right? So if x minus 2 is a factor, that means that I'm going to be able to divide what I have left over by one of the solutions so I can get all the rest of the solutions. So this is my original, and this is my divisor, because this is what I'm going to go ahead and divide into this longer polynomial. So when I set up my work, I'm going to go ahead and put 3x cubed, and then minus 7x squared plus 9x, and then minus 14. All of that is going to go underneath the square root symbol. And then I'm going to divide by x minus 2. That's going to go on the outside. Notice here that all of my exponents are in descending order. I'm going to make a little note here. Exponents in descending order. Exponents in descending order. We know descending order means we start with the highest exponent and then it drops by 1. So we are in descending order and we have every exponent. We're not missing any, okay? That's going to be a big deal later on. So for this one, we are set up correctly. We can go ahead and start to divide. Since I have two terms on the outside that I'm trying to divide to this long polynomial, I'm going to pay attention to the first one because that's our largest one. So I'm going to look at x. How does x divide 3x cubed? In other words, what could I put up here as my first part of my answer that would multiply and cancel out the 3x cubed? So I'm going to need a 3. I'm going to need a couple x's. Since I have 1 here and I'm trying to make 3, I'm going to put 2. All right, that was my divide step. So my next step is to multiply, then subtract, then bring down. Okay, so multiply is next. 3x squared multiplies by x, and I get 3x cubed. That works out really well, because when I subtract, it will cancel. Since I have two terms here, I need to make sure that I distribute to both terms. So 3x squared times x is 3x cubed. 3x squared times negative 2 gives me negative 6x squared. Okay? Now here, another part where I'm going to write in blue. Important part. Subtract. If I subtract, that means that this subtraction sign has to apply to this first term and has to apply to the second term. So it is going to change this to a plus sign. Negative, negative makes a positive. So I have to make sure that I distribute that negative to both of these terms. Okay? Subtract 3x cubed minus 3x cubed, I have nothing left. 7x, negative 7x squared plus 6x squared, I get negative x squared. Okay, I'm going to go ahead and bring down plus 9x, and then I'm going to start this process again. X divides into negative x squared. I can multiply negative x times x gives me negative x squared. I need to distribute so that I can have another term as well. Negative x needs to also multiply by negative 2, which is going to make positive 2x. Again, I'm going to grab my blue because I need to subtract. But look at this. If I subtract negative, negative, these are going to become positive. Negative times this positive is going to make this negative. So I really have negative x squared plus, because I have a double negative, another x squared. That makes 0. 9x minus 2x is 7x, positive 7x. And then I'm going to bring down my last term, which is negative 14. X divides into 7x. I'm going to go ahead and put my 7 here. If I multiply 7 times x, I get 7x. Okay? And I distribute, so 7 times negative 2 makes negative 14. I am going to go ahead and subtract, grab my blue. So this is becoming negative, and this negative times negative will become positive. So here we go. 7x minus 7x is 0. Negative 14 plus 14 is 0. So I have no remainder. All right, so it divides evenly. Well, wonderful. So now I know that 2 divides, which is why we have a 0. So 2 is a 0 because it divides my polynomial, which means it's a factor, and it would equal 0 and make 2. All right, so I have 2 as one of my answers. Now the rest of this, I'm going to go ahead and extend my page a little bit. All right, so the rest of this means I now have 3x squared minus x plus 7, and I'm supposed to be able to find the rest of my zeros. Well, I know one of them is x equals 2. The rest of them, though, are from this leftover part, the 3x squared minus x plus 7. So if I want to find the leftovers, now that it's just a trinomial, I can set it equal to 0, and I can factor the way that I've been doing, like we did the last couple days. Okay? So if I factor, well, I have a leading coefficient of 3, so I'm going to, and I don't have a GCF, I don't have a greatest common factor, so I'm going to slide and divide. See if I can get anywhere that way. So now I have the x squared minus x, and I have a 21. Is there a combination of numbers that multiplies to make 21, but adds to make negative 1x in the middle? So I've got 7 and 3, 1 and 21. Does not work. So can't factor. That means the only way that we can solve this is by using the quadratic formula. So let's go back. Let's use our 3x squared minus x plus 7 again. It's equal to 0, so I'm trying to solve for x, and x is equal to negative b plus or minus the square root of b squared, which is negative 1 squared, minus 4ac, all divided by 2a. Okay? All right, guys, so if I wind up doing the quadratic formula, I get the square root of a negative number. So that means that I have 2 imaginary roots. So I only found 1 real root because it divided evenly when I was doing my long division. And then with the leftovers, so I've got 1 real root of x equals 2. But with the leftovers, I just got 2 imaginary roots. So that's all I found. This is called solving using long division. And again, it's because I can't factor all 4 of these. Or sometimes I can, but sometimes long division is a little bit simpler. This is another example for long division, but if you notice, it's missing an m squared term. So when we set it up, we have to put a placeholder in with a 0m squared. Otherwise, long division won't work, and synthetic division won't work either, which is going to be your next way to do this type of problem. However, we have to have 3, 2, 1, and then constant at the end. You've got to always start with the highest and then drop by 1 when you set it up. So go ahead and pause the video here, try this one, and then push play to check. Since this problem has a remainder, this m plus 2 does not divide into the original numerator, which means that negative 2 would not be a solution or a 0 for this polynomial. All right, so the remainder tells us that. All right, so quickly I'm going to show you guys what synthetic division is all about because it's a quicker way to do long division. If you're dividing by x plus 1, we are going to use negative 1, which is the actual 0 of the problem, right? We're going to set up negative 1, and I'm going to put a little box around it, and then I'm going to use only the coefficients, okay? So that means I'm going to take 5, I'm going to take 7, I'm going to take negative 1, and then I'm going to take negative 3, which is my constant. So I take the coefficients and the constant. If I'm missing a term, I have to put 0 in as a placeholder. So down here, I would have to use 0 for the placeholder for x. The way that the pattern works is the first number drops down, so I put 5. Negative 1 multiplies by 5, and I get negative 5, and then I add. 7 minus 5 is 2. Then I repeat. Negative 1 times 2 is negative 2. I add negative 3. Negative 1 times negative 3 is 3. I add. I got 0. 0 becomes the remainder. We drop one power, so now we have x squared to start, x, and then constant, and this is